Hello, function stat and triggers. On this great day, we're going to use sine, cosine, and tangent to find missing side lengths of a right triangle. So remember that when we are approaching word problems, some of the smartest things to do is to draw a picture. Remember that you might have to erase a few times in order to make it look good. We're going to label the given parts, and we're also going to label what we're trying to find. Remember, some things might remain unlabeled because it's irrelevant to the current situation. And then we're going to set up the appropriate trig ratios and then solve. So again, we might not need all of them. All right, so let's take a gander at example number 1. From the top of a tower, the angle of depression to a stake on the ground is 60 degrees. The top of the tower is 80 feet above the ground. How far is the stake from the foot of the tower? So we've got some sort of a tower. And we have some sort of a stake on the ground. So we do have clearly a triangle being formed here. And of course, what we're trying to determine is what the relevant information is. Something else to consider is I'm going to need the horizontal line from the top of the tower. The reason for that is because this says specifically the angle of depression. An angle of depression always goes from the horizontal, just like an angle of elevation goes from the horizontal as well. So if this is 60 degrees right here, clearly not to scale, so I'm going to resketch it momentarily. This one here will also be 60 degrees. Why? Because parallel lines cut by a transversal, alternate interior angles are congruent. And we also know that this is 80 feet over here. And we're actually looking for the distance from the stake to the foot down here. So we're not looking from the stake to the top of the tower. So if I were to resketch a little bit, I do want 60 degrees more like so. And so here's my tower. 60 degrees, more like this. So in this case, that's a 60 degree right there. This is 80 feet, and we're looking for this unknown distance right there. Now, if you actually remember your special right triangles, it turns out that to get from here to here, you just need to divide by radical 3. But we won't get into that right now. Let's just go ahead and figure out which sine, cosine, or tangent we need. Relative to this angle right here, this is my opposite, and that is my adjacent. So opposite, adjacent, so that means I'm going to use tangent. So the tangent of 60 degrees is equal to the opposite 60 feet over the unknown distance. Now, how do we solve this? The simplest way is just to jimmy jig these two terms. The whole tangent of 60 switches with the d there. Why is that the case? Let me just walk step by step. If I multiply both sides by d here, in order to get d by itself, that means I also have to divide by the tangent of 60 over here in order for those to drop out. So if I divide by the tangent of 60 on this side, notice my end result is 60 divided by the tangent of 60. Excuse me, and this here should be 80 feet. So let's change that. And because of that, it's as simple as whenever we have this in the denominator, we can just do a quick switch there. So here's actually going to be the solution, 80 feet divided by the tangent of 60 degrees. So we're going to punch that into our calculator to get an approximate value. And we get approximately 46.2 feet. So how far away is the stake from the tower? About 46 feet there. All right, let's take a gander example 2. A ladder leaning against a house makes an angle of 72 degrees with the ground. The foot of the ladder is 7 feet from the foot of the house. How long is the ladder? So here we have a house, and the ladder makes a 72 degree angle with the ground. So that means 72 degrees is going to be right here. And we know that the ladder is 7 feet from the house. So this here is 7 feet. Okay? And the question, of course, is how long is the ladder? So we are ultimately trying to find out this distance right there, the red ladder. All right, so again, we examine based on this angle here. Opposite is unknown and irrelevant. So I have adjacent here and hypotenuse there. Adjacent, hypotenuse, so that's going to be cosine. So the cosine of 72 degrees is equal to the adjacent, which is 7, over the unknown x. Again, just like in the previous example, all I have to do is take those two and switch. So x is going to be equal to 7 over the cosine of 72 degrees. And now I can plug that in to find my approximate value. And my end result is 22.7 feet. So bringing it back to context, how long is the ladder? The ladder is 22.7 feet long. The next example that we are looking at is example number 3. You are a block away from a skyscraper that is 780 feet tall. Your friend is between the skyscraper and yourself. The angle of elevation from your position to the top of the skyscraper is 42 degrees. The angle of elevation from your friend's position to the top of the skyscraper is 71 degrees. To the nearest foot, how far are you from your friend? Oh my goodness. So we have a skyscraper here, and we are told it is 780 feet tall. Now there are two of us. I am a block away, way over here, and it says that the angle of elevation here is 42 degrees. So let me draw a ground as well. 42 degrees. Now, my friend is standing much closer, and that angle of elevation is 71 degrees right here. So notice what we're actually trying to find. I need to find how far away from my friend I am. So a safe assumption here is that the building is 90 degrees there. So the question is, how do I find this piece? This piece. Well, there's a couple ways to approach it, but let's also consider the individual parts here. I do need to know how far away I am from the building and how far away my friend is from the building. And when we subtract those, we get the end result. So I need to find out what x is right here, my friend's distance from the building, and then I need to find out how far away I am from the building, and we'll subtract those. So focusing in on the small right triangle over here, we know the opposite. We're looking for the adjacent, opposite, adjacent. That means I'm going to use tangent. So the tangent of 71 degrees is going to be the opposite over the adjacent. And when we jimmy-jig those, we get the tangent of 71 in the denominator. And x is approximately 268.6 feet away. Now, the same idea can be applied here. To find out y, we're going to do the same thing. Again, we know the opposite here is 78. We don't know the adjacent, so that's going to be tangent again. But this time it's the tangent of 42 degrees is equal to 780 feet divided by the unknown y. So y is going to be 780 divided by the tangent of 42 degrees, and y is approximately 866.3 feet. And now our last thing to do is just subtract. We need y minus x in order to get the distance from my friend to me. And it yields me approximately 597.7 feet. So to answer that question as a sentence, I am, and it says nearest foot, I am about 598 feet away from my friend. The last question we're going to do is example 4. And you are standing at point B, so here I am, along the shore of a pond. At point A is a rock that you know is 250 feet from you. Using the diagram, if your friend is standing over here on the shore, point C, how far would you have to swim to get to her? So swimming across or kayaking or some other thingamajigger, get over there. So I'm going to use these angles and this distance there. However, one thing I notice is that this is not a right triangle. So if I were to take a moment and draw a right triangle, I now have 90 degrees down there. And instead of having 110 here, let me cross that out. This angle here is going to be complementary to this angle here because of the right triangle. So that means this one here has to be 48 degrees. And now when I subtract 110 and 48, this angle here is 62 degrees. So by extension, I can also find out what this angle is right here, which is 28 degrees. Okay, now continuing on, I need to find out what this distance is right here, all the way across. So I do know 250, which means I can use trigonometry to find out this red altitude. And then from there, I can go on and use this and this angle to find out that distance there. So I'm going to start by finding the altitude. I'm going to label that to be x, and then over here I'm going to label the ultimate answer to be y. So based on this right triangle here and at 42 degrees, this is opposite hypotenuse, so I need sine. So the sine of 42 degrees is going to be x over 250. So x is approximately, again, I need to multiply 250 on both sides, 167.3 feet. And now I can use that value here and the 62 degrees. So relative to 62, this one is my adjacent, and that is my opposite, or excuse me, hypotenuse. So adjacent and hypotenuse, that's cosine. So I'm going to do the cosine of 62 degrees is equal to 167.3, and actually let me change that from equals to approximately equal, because the 167.3 is an approximation. So 167.3 over the unknown y. Remember, I can just switch those two to get 167.3 divided by the cosine of 62 degrees. And in the end, I get approximately 356.3 feet. So how far do I have to swim? A little bit more than 350 feet. And relative to my diagram, if this is 250, 350, this does make sense. Now, this is not drawn to scale, but at least makes some sense there. All right, the remainder of your assignment is to finish all of the pages and also working on the radian worksheet. Have a great vacation.